Hello and welcome to TN Academy. Today we're doing question 8. We're given a part A and part B, but we will be starting with part A. For question 1, we're given an acute angle theta such that cos theta is equal to 2 over 3, and we're asked to find sine theta and sine 2 theta. So to answer our first question, we will use Pythagorean's theorem. Now with the Pythagorean theorem, we get the identity that cos squared theta plus sine squared theta is equal to 1. And we do have cos theta, so we can substitute that into our equation so that we get 2 over 3 squared plus sine squared theta is equal to 1. And then if we isolate for sine squared theta, we get sine squared theta is equal to 1 minus 4 over 9. And we can, of course, do the subtraction and take the root of our right side to isolate for sine theta, which is equal to root 5 over 9. And that's our question for, that's our answer for question I. And for question II, we have to use, we're asked to find sine 2 theta, so we have to use the double angle identity, where sine 2 theta is equal to 2 sine theta cos theta. It should be written as 2 cos theta sine theta. But regardless, we have both sine theta and cos theta, so we can evaluate for sine 2 theta by substituting our values into the equation so that we get sine 2 theta is equal to 2 times 2 over 3 times root 5 over 9. And then if we expand our expression, we get that this is now equal to 4 over 3 times root 5 over 9. And we can take out our root 9 and multiply our denominators to get a nicer looking expression of 4 over 9 by root 5. And that's our answer to question II. What is sine 2 theta? Now for part B of our question, we are given a triangle now, ABC, where B is in reference to angle theta, and point A is in reference or has the angle 2 theta, and BC is equal to A, and AC is equal to B. Now for our first question, we're asked to show that B is equal to 3A over 4. So we recall our previously found values of sine theta and sine 2 theta, and we can use two formulas to prove this, which is the sine rule and the double angle identity law. Now I will be using the sine rule to do this, but both will yield the same answer. So when we substitute our two values into the equation, which would be root 5 over 9, 4 over 9 root 5, and root 5 over 9, which has been written as root 5 over 3, which means the same thing. Then we get b over root 5 over 3 and a over our value for sine 2 theta. Then when we simplify by cross multiplying our denominators, we get 4 root 5 over 9b is equal to root 5 over 3a, and then since both sides have root 5, we can actually cancel that out so that we get 4 over 9b is equal to 1 over 3a, and if we isolate for b, we find that we get b is equal to 9 over 3 times 1 over 4a, which is just 3 over 4a, and that's our answer for that question. Now on to question C. We are given a new triangle, an isosceles triangle. The question states, what if BA was extended to form an isosceles triangle? So now we have AD, an isosceles triangle DAC, with D being theta. What is the value of CAD, which is the angle opposing A or opposing 2 theta? So to solve this, what we can do is use supplementary angles, since our angle CAD and BAC are supplementary angles, which means they add up to 180. And our identity for supplementary angles is the following, where sine CAD is equal to sine BAC, which is also equal to sine 2 theta. And I hope that's familiar because we already know what sine 2 theta is, and that is 4 over 9 root 5. So that is our answer to that question. Now for our final question, we are asked to find the area of triangle DAC in terms of A. So, to start, we know that the area of a triangle is 1/2 base times height. There are two things we have to recognize here, that DCA is equal to theta, and that our side AD is equal to B, which is 3A over 4, as we can recall from before. So there are three different ways we can actually solve for area, where we either evaluate 1/2 B side B times 4 root 5 over 9. We can additionally use sine 2 theta, and we know that sine 2 theta is also a sine of CAD. But either way, if we substitute all of our values into either of these equations, we should get the following, which is 1/2 3A over 4 twice by 4 root 5 over 9. So that we get the area, which is root 5A squared over 8. And that is one of the ways to get the answer for this question. And that is all for your question today.